Welcome to The Explainer. Today, we're jumping straight into a massive paradigm shift from the 1960s. We're talking about the moment the computer went from being this giant passive calculator into an actual interactive intellectual partner. We are diving into the visionary mind of J.C.R. Licklider and the dawn of man-computer symbiosis. And look, this isn't just some dusty hardware history. This is literally the foundation of how you and I interact with technology every single day.
Okay, let's dive into this with a pretty huge existential question. What if computers weren't actually meant to replace us, but to merge with us? You know, for decades, the sci-fi narrative, and honestly even the view of a lot of early computer scientists, was that AI would eventually just become fully autonomous and render humans totally obsolete. But what if the ultimate goal of computing was never automation at all, but augmentation? To really grasp how this idea flipped the world upside down, we gotta look back at just how painfully restricted early computing actually was.
Picture the absolute friction and isolation a scientist faced in the 1950s. Back then, computers were these remote, bureaucratic oracles, completely locked away behind glass walls. You couldn't just sit down and type on a keyboard like we do now. Computing was entirely defined by what's called batch processing. A programmer would write out code, physically punch it onto a massive deck of cards, hand that deck to an operator, and just walk away. It was this incredibly isolated experience, where the machine was completely walled off from the human mind it was supposed to be helping.
So the real bottleneck here comes down to a massive clash of speeds. On one side, you have the agonizingly slow weight of batch processing punch cards, taking hours or even days. And on the other side, you have the instantaneous, fluid, associative flow of human thought. Because the delay between inputting your problem and actually getting an answer was so huge, the coevolution of human and machine was completely fractured. Think about it. If a scientist had to wait 24 hours just to see the result of one tweaked equation, the momentum of their thought process is completely shattered. The computer was literally acting as a roadblock to discovery, not an accelerant. Something desperately needed to change.
And all that frustration brings us to this absolutely staggering number, 85%. J.C.R. Licklider, who was this brilliant psychoacoustician and computing pioneer, actually did an informal study of his own daily habits as a working scientist. And he had this incredibly frustrating epiphany. He realized that about 85% of his thinking time was actually just spent on repetitive, manual, clerical tasks. He was literally just getting ready to think. He was plotting graphs by hand, hunting down values in massive tables, digging through databases. Only a tiny fraction of his day was actually spent on creative formulation and making real decisions.
Licklider knew, right then and there had to be a better way. So, in 1960, he drops this landmark paper outlining his big idea, man-computer symbiosis. He defined it as a cooperative living together of human and electronic components designed to tightly couple human brains and computing machines. And he made it crystal clear. This was not about artificial intelligence coming in and replacing us. No way. This was about a dynamic, interactive partnership. The computer handles the tedious, routine data crunching, and that frees up the human mind to focus entirely on the complex, creative leaps.
I absolutely love this quote from his paper, and I really want you to absorb what he's saying here. He wrote, "The resulting partnership will think as no human brain has ever thought and process data in a way that no information handling machine we know can approach." This philosophy completely elevated the entire field. It wasn't just about building faster hardware anymore. It was a massive epistemological shift. Licklider was literally predicting an entirely new species of thinking.
Now, what's really interesting about this is how Licklider proposed splitting up the cognitive labor to make this symbiosis actually work. You have the human partner, who handles heuristics, goals, hypotheses, and creativity. We excel at setting the direction and making those weird intuitive leaps. The machine partner, on the other hand, handles the algorithms, the rapid calculations, the massive memory retention, and the database searches. The genius here is that by working together in real time, the human brings the creative spark and the machine brings the instant computational muscle.
But for any of this to actually happen, Licklider knew they had to completely destroy that time lag between humans and batch processing mainframes. So he laid out a technical blueprint. First up, time-sharing systems. This would slice up a single mainframe's computing power among multiple users all at the same time, so it actually felt like real-time interaction for everyone. Second, instantaneous memory hardware, letting you retrieve complex data right away. And third, interactive graphical interfaces. We're talking high-resolution displays so humans could visually interact with the computer instead of just reading strips of paper tape. These were the absolute non-negotiable prerequisites to make sub-second cybernetic interaction a reality.
Now, having a brilliant vision is great and all, but making it real? That takes serious resources. In 1962, Licklider got appointed as the first director of the newly formed Information Processing Techniques Office, or IPTO, which was part of ARPA, and he totally used this powerful director position to funnel millions of dollars in funding straight to research labs across the U.S. He essentially bypassed all the slow, traditional academic red tape to fund these brilliant, unconventional researchers who could actually turn his symbiotic concepts into physical reality.
And one of the absolute most important recipients of that ARPA funding was a visionary engineer named Douglas Engelbart. Working out of the Stanford Research Institute, Engelbart completely shared Licklider's passion. But his specific obsession was maximizing the cognitive bandwidth and the collaborative capabilities of professional teams. He took that funding and explicitly set out to augment human intellect. He wanted to build an interactive digital environment where researchers could seamlessly organize, navigate, and collaborate on massive networks of information.
Let's track how this builds, because the theoretical momentum here is incredibly fast. In 1960, Licklider drops his man-computer symbiosis paper, setting the whole theoretical stage. Just 2 years later, in 1962, Engelbart publishes his conceptual framework on augmenting human intellect, structuring this whole philosophy around a human-tool feedback loop. And then, fueled by that ARPA funding, all this theory culminates in 1968 with an event that became legendary, the mother of all demos.
December 9, 1968, a computer conference in San Francisco. I want you to picture this scene. Douglas Engelbart walks out onto a stage wearing a wireless headset microphone, which was wild for the time, and sits down at this custom-designed console. He is about to deliver a 90-minute, completely live presentation to 1,000 highly skeptical computer professionals, and in that hour and a half, he entirely shatters the batch processing paradigm forever. He presented a technological revolution that quite literally mapped out the next half-century of computing. During this presentation, Engelbart unveiled what he called the Online System, or NLS, and he introduced an astonishing arsenal of interactive technologies. He debuted the computer mouse. He showed off a 5-key chord key set that let you type with one hand. He demonstrated structured hypermedia, so users could navigate nonlinear documents. He even showed off real-time screen sharing and video conferencing. Right there on stage, live, he proved that a computer could be a deeply expressive, personal, and highly collaborative tool.
But the true magic of the NLS was how it physically created a cybernetic control loop. Let's break down the incredible coupling tightness of using that brand new mouse. Step 1, your hand moves the mouse. Step 2, the computer instantly detects this and updates the cursor's coordinates in its memory. Step 3, the CRT monitor redraws those coordinates on the screen. Step 4, your retina processes that visual feedback, allowing your brain to adjust your hand's movement. This seamless, continuous feedback loop between human and machine was happening in mere milliseconds.
And this brilliantly illustrates how the interface transformed the computer into an auxiliary cortex. Because the interaction was so impossibly fast and intuitive, the interface itself practically vanished. It felt like a transparent extension of the human nervous system. You weren't just typing commands to some distant machine anymore, you were engaging in this fluid, iterative dance of action and feedback. The computer became an external medium that could process, preserve, and reflect your thoughts in real time, holding your complex mental models so your brain was free to focus on higher-level creativity.
This newfound technological freedom directly challenged the old, restricted ways we were used to consuming information. Think about it. For centuries, we've been bound by the tyranny of the printed codex. Books and physical papers force you into a linear model of reading and writing. You're a passive consumer, just following a single, predetermined path from page 1 to page 2. But here's the thing. Human thought doesn't work that way. Human thought naturally operates through a chaotic web of association and immediate cognitive leaps.
Which brings us to the sheer brilliance of hypertext. By mapping the nonlinear, associative architecture of human memory directly onto the machine, the user magically transforms from a passive reader into an active explorer. You can navigate custom pathways, jumping from one idea to a related concept instantly, building this rich, decentralized network of knowledge. For the very first time, the interface actually matched the associative, jumpy nature of the human mind.
But Engelbart absolutely didn't stop at just individual augmentation. The real climax of his 1968 demo was the birth of collaborative computing. Using a microwave link, Engelbart connected live with his colleague Bill Paxton, who was sitting at a terminal 30 miles away. Up on the massive auditorium screen, Paxton's face appears in a video window, and a second cursor pops up on the document. The audience just sat there in absolute astonishment as these two guys, separated by 30 miles, seamlessly edited a shared document in real time, just conversing naturally. They proved that geographically dispersed minds could actually unite in a shared digital sandbox.
Now, it's really interesting to see how the industry evolved from this specific moment. While Engelbart wanted to maximize the capabilities of complex professional teams solving massive global problems, the tech industry later shifted slightly. Places like Xerox PARC took these incredible interface concepts but focused on creating intuitive, highly accessible interfaces for individual, everyday users. This divergence gave us the simpler, user-friendly personal computers that totally dominated the consumer market, prioritizing ease of use for the individual over that highly complex team augmentation.
Engelbart actually had a really tasteful, slightly humorous take on this shift. He argued that forcing digital tools to mimic the limitations of the physical world, like, say, treating a digital document exactly like a static piece of paper, really constrained our cognitive potential. He said what humanity desperately needed were complex helicopters for the mind. Yes, tools that require significant training to use, but that offer unparalleled freedom and power to solve big existential problems. He felt the commercial industry instead opted to build digital bicycles, simple tools anyone can ride immediately, but totally lacking that structural depth.
So, the crucial point to take away here is that the profound legacy of Licklider and Engelbart goes way, way beyond inventing the mouse or the graphical interface. Their core philosophy of connection and their relentless drive to create interactive, shared workspaces directly birthed the ARPANET, which of course evolved into the modern internet. They provided the essential answer to why we should connect these machines in the first place, to connect human minds, to democratize knowledge, and to collaborate on a global scale. The deeply collaborative nature of the internet we rely on today is quite literally the ultimate realization of their symbiotic vision.
Which leaves us with a final, pretty provocative thought to ponder. As we engage with these incredibly responsive, connected systems every single day of our lives, we aren't just using tools anymore. We are part of a continuous, second-order cybernetic loop. When we use these cognitive tools, we are actively redesigning our own cognitive architectures. So in this continuous, co-evolutionary loop, are we shaping the machine, or is it shaping us? It's a fascinating question. Thanks so much for joining me on this explainer, and keep exploring.